Perfect. Thank you very much, everyone, for coming today. I'm Adrian, and today I'm going to, very briefly, in the next 20 minutes or so, introduce you to Anoma, which really is the first generalized intent-centric architecture. And just to start you off with this, the next wave of blockchains is going to be built around intent-centric architectures. There is almost no way around this, because what we're starting to realize, sort of given the applications that have emerged since Ethereum was built, is that transactions are really bad fundamental building blocks for 90% of all applications. Like, transactions make a lot of sense if they contain the entire state transition, right? Like, if you go to a store and you buy some milk using Bitcoin, transactions make a lot of sense, because this is a fully fledged state transition that is immediately executable on chain. Most of the applications we have nowadays, whether this is some MEV front running or some rollup or some multisig, they all evolve around partial state transitions, or what we call intents. And the idea here is that intents are partial, as in they can't be settled directly on chain. They have to have some other counterparty with whom you can interact in order to make them settleable, in order to make them fully balanced. And so the most trivial example here is a multisig, actually. It's like a 1 out of 2 multisig. The 1 out of 2 multisig is already an intent, because when I have my component of that multisig, this is not something I can actually execute on chain. I need some other person's signature as well to make this into a fully fledged thing that is executable on chain. But before we get too deep into this, and all the implications we have around decentralizing sequencers and decentralizing rollups and privacy, I'd like to go through a brief evolution of protocols here. So really, we started off with generation 1, or what I'd call scriptable settlement. And this is really everything around Bitcoin and Bitcoin-like systems. And they are fantastic platforms to build things like cryptocurrencies, things like colored coins, Namecoin, and the long tail of Bitcoin-like forks. But they are fundamentally limited. You can't really build applications on top of them. The best thing you could do was sort of you fork the C++ code base, and then you slap a new name on it, implement some new opcodes in your script, and now you have a new blockchain. But we didn't really have application development as such on these systems. And really, as a result of this experience, we got to generation 2, or what I'd call fully programmable settlement. So Turing-complete execution environments where application developers could write some code and deploy to them. And all of a sudden, colored coins became ERC20s, Namecoin became ENS, but we also got a whole new host of applications like DAOs, new kinds of assets, and everything that sort of has happened since Ethereum came out in 2015. I'd also like to briefly go through programmable settlement ++. And I think I may ruffle some feathers here, but to me, really, we are still in generation 2. We haven't evolved from this. When we look at things like Near, Solana, Polkadot, Avalanche, you name it, it doesn't really matter. They're all fundamentally transaction-centric designs. They're not intent-centric designs. They are designed around sequentially executed VMs, where the user that signs the thing needs to have access to the entire state transition and settled in order to execute it on chain. However, of course, we've made tremendous advances in things like Sybil resistance, advances in scaling, advances in privacy, advances in consensus. But fundamentally, the model did not change of what developers had access to and what kind of applications could be built using these systems. So, this is what most of the talk today is about, intent-centric architectures, intent-centric design. And really here I'd like to introduce Anoma, which is the first specification for a fully generalized intent-centric architecture. And really, how did this come about? Well, we start from first principles, like what is the fundamental building block that users have? And when you look at an example like OpenSea, the fundamental building blocks that users have is not a transaction, it's an intent that your user signs and submits to some Web2 server in San Francisco that then collects a bunch of these intents, does some compute to this, and then settles it on chain. And this model generally extends, whether this is OpenSea or some other NFT marketplace, whether it's Darknet, whether it's any rollup of your choice, pretty much currently works this way. User signs a thing that is not directly executable on chain, sends it to some Web2 server does some compute to it, and then executes on some other settlement system. And just to highlight how prevalent this is, Gnosis Safe works the same way. Like, what actually happens when you interact with the Gnosis Safe UIs is that you do your individual part of the multisig, which then gets uploaded to a central server, probably running in Berlin somewhere, and the last person, before submitting the entire multisig transaction on chain, pulls all the individual constituent signatures from chain, wraps them into one single transaction, and submits them. So really, this design pattern of intent-centric design is everywhere. The big problem is that until sort of 2021, no one had named this. Like all these applications were building custom solutions around this. Some were trying harder than others to make this actually decentralized, but no one had tried to build this from first principles with like what happens if we think about our systems not as transaction-centric systems, but rather as intent-centric systems. So with this, coming to what is Anoma? Anoma is the first ever intent-centric architecture, introducing a new paradigm for building infrastructure layers. This is really, the idea is that it is designed from the ground up for applications that involve infinite number of users issuing infinite numbers of intents, each of arbitrary complexity. And here it's important to understand that intents are just code. That's it. It's state and code. You can write whatever you want in an intent. This gives you the very cool ability to have very complex multisigs, for example, because you can write things, I'm willing to authorize my 1 out of 3 part in this multisig if the weather is nice in Paris, and if the weather is not nice in Paris, I want to sell all my ETH, right? So you can write whatever you want. This also extends into rollups. I want to be in some optimistic rollup. I don't care which color it is. I just want to be in the next one, given that it has XYZ security guarantees. And really, this is a much better model for what users actually do, because users express what they want, not how to get it. And currently, users really express how to get it, because when you think of what an Ethereum transaction looks like, an Ethereum transaction is some contract call with some opcode and some entry point, right? And a user signs over effectively a stack trace or an execution trace of allowed compute over their state. They don't define a specific state change. Wallets may make it look like a user, when they sign something, they like sign over a transaction or a trade against Uniswap, but that's not in reality what happens. What a user signs over is they sign over a number of EVM opcodes that then can result in some state change. And intents, on the other hand, just sign over specific state changes. They say, I am willing to trade A for B at this price, and I don't care how the execution of this happens. So in that sense, intents are binding programmatic commitments to preferences. And the fact that intents get signed, intents are specific state changes matters a whole lot for both composability as well as for decentralized counterparty discovery. Because all of MEV, or not all, but most of MEV comes from the fact that we sign over execution traces. And now interleaving matters, right? Like if user A's execution trace gets executed before user B's execution trace, we may end up in some other state. So the ordering starts mattering. Whereas in intent, since you've signed over fully fledged state changes, I can apply them in either way, and they still result in the same state in the end. Maybe the second part is not settable anymore, but I'm never in this position where like my execution depends on what other execution happened in front of me. Yes, and this leads to a very nice declarative paradigm for dApps, where a user really just submits what they want to do. So they submit like, I'm willing to trade this one NFT for 1 ETH. And then the system can figure out how do I settle this? Like, how does this actually get settled in practice? It's not the user has to figure out, oh, I want to go to this specific marketplace to interact with it. The user just says, I'm willing to commit to this state change. And solvers have a look. Maybe there's 1 AMM, maybe there's 15 AMMs, maybe there's some off-chain compute that needs to happen. The user does not have to care what the execution trace looks like. The user only has to care that they correctly specify the state changes they are willing to take. And in the end, if it's possible to settle, then it's settled. If it's not possible to settle, then it's not settled, right? Like, intents don't guarantee that you can trade things that no one else wants to interact with. And the best part of this is that this makes privacy-preserving applications way easier to build. Because currently, users have to make choices on, do I go to this privacy-preserving DEX or do I go to this transparent DEX? So a user has to make an upfront choice on which application they want to interact with. With intents, users only have to write their intents, and then certain parts of the intents can be private or transparent. And this is up to the user. So we're removing this capability that applications make a choice on privacy versus transparency and make it a user choice. Users all interact with the same DEX, but individual users can make choices that they individually want to be private when interacting with the system. And here, really, private means this could either be using ZKPs, or eventually, once it gets fast enough, fully homomorphic encryption for even better privacy guarantees. But besides that, really nothing else changes, because one of the coolest things is that the intents are still composable. So between transparent and private intents, they're still composable. So if I want to trade ETH for Bitcoin transparently, and someone else wants to trade Bitcoin for ETH privately, a solver can pick up both of these things and settle them on-chain in the same application. And I'll come more into this later, but what is really important here is that it's an architecture. It's not a specific blockchain. This is intents for Ethereum. This is how you decentralize current applications on Ethereum, or how you bring intents to Ethereum, really. This is sort of an overview of the entire architecture. And just from left to right, very briefly, you have intents. Users can issue them. Again, they make choices at the user level, not the application level, whether they want to be transparent shielded or private, where transparent shielded and private really corresponds to transparent, ZKPs, or FHE. They then submit this to the intent gossip network, which is a globally non-consensus critical sparse network that just gossips intents around. Solvers can hook into this and go, I care about all the Uniswap intents, I care about all the OpenSea intents, or I care about all the, I don't know, Gnosis Safe intents. Solvers then figure out which intents are compatible with each other, i.e. which intents fully fledged or fully balanced state transitions. As in, if I trade 1 Bitcoin for 1 ETH, someone else has to take the inverse. If no one else is willing to take the inverse, this is never settleable. And this is what solvers do. Solvers then submit this on chain to an encrypted mempool using Fervio, so they're not front-runnable. Validators execute this, and then sort of on the far right, we get into the execution environment, which makes all of this possible, which is Tiger. And Tiger really is it's a Halo 2 ZK circuit, which also enables Anoma to be deployed as a ZK rollup to Ethereum. This is sort of, Anoma is completely oblivious to the security model in which it is deployed. Users can choose to deploy Anoma onto Ethereum as a ZK rollup, thereby bringing intents to Ethereum. They can choose to deploy this to some corporate chain run by Volkswagen. Like, the architecture doesn't care. The nice thing is, intents are still span the entire deployment model of all Anoma instances. Because my intent can say I'm willing to be either settled on security model X or Y. So for example, I could say I'm willing to trade on Ethereum, but I want to take delivery of my assets on Solana, for example. So all these kinds of things are possible nowadays. Yeah, going a little bit through the stack. So we have Tiger, which is the execution environment. If you're into cryptography, check it out. It's very cool. There are demos that are running right now. Then you have Typhon, which I really haven't spoken about the consensus part yet of Anoma, but the nice thing is we can make way more advances post sort of what is possible with fast finality with modern BFT systems. And so you can think of Typhon as an evolution of something like Tendermint, which allows you to get multi-chain atomic settlement working. That I can say, if blockchain A and blockchain B have a large enough overlap in their validator set, we can do a on-demand shard between these two systems. Then we have Vampire, which is, if you're familiar with programming language, it's LLVM for polynomials, so that you don't have to worry about writing for a specific circuit backend, but rather you write in Vampire, and then the compiler figures out whether you want a Plonkup backend or a Halo 2 backend. Currently, Plonkup and Halo 2 are supported. Experimental support for Starks is also in the work, as well as an FHE backend. And then you have Juvix, which is really the high-level language that targets Vampire. I would expect that in the future, most developers will never write Vampire. Like, Vampire is more of a compiler target. I would hope that we get good enough high-level languages where, like in the case of Juvix, as a developer, you don't have to think about what a field element is anymore. Like, it abstracts the cryptography away from the sort of application development side of things. Yeah. So what can you build with Anoma? And this should really say, what can you decentralize with Anoma? Because you can either build this on global Anoma, but you can also use Anoma to decentralize these systems on Ethereum nowadays. You can use this to decentralize your optimistic rollups or even your ZK rollups. You can use Anoma to decentralize your NFT marketplaces and lots of other things. This is like sort of like once you start diving deep into how 90% of our infrastructure is run, it generally always ends up at somewhere at AWS. And really, this is Intents the solution to start fixing this going forward, even for legacy applications. There's a host of things, though, that you can't build on existing systems. So some of you may have realized that with intents, they're just partial state transitions from A to B. You just get rollups for free. Because if I have an intent from A to B and someone else has an intent from B to C, any solver in the network can just create an intent from A to C, thereby creating a partial rollup. This is also actually really important in order to have solvers not waste tons of computes, in the sense that you can get paid for doing partial compute that is still valuable. You can also do things like multi-party, multivariate bartering, DeFi dApps such as sealed bit second price auctions, or privacy-preserving DAOs. I will skip over this for the brevity of time, but maybe sort of the really important thing to understand is this kind of architecture makes building applications about an order of magnitude easier and makes applications about an order of magnitude more composable. Because currently, as an application developer, you have to sort of worry about pretty much this entire page. Whereas with an intent-centric architecture like Anoma, you only have to worry about building the application piece, so that box there, and having an intent format that solvers can operate with. You don't have to worry about how do I build a backend on AWS that aggregates all these intents, then submits them as batches to some set of solvers, enforce some bounding constraints on those solvers, and so on. Really, the important thing to remember is when Ethereum came out in 2015, really we didn't know what was going to happen. Like, we had a rough idea of some cool applications that may come about, but we couldn't really spell out all the applications that we'd have nowadays. And I think it's the same with Anoma and Anoma-like architectures. Really, what intents enable, we're just scratching the surface of that. Yes, so Anoma is an architecture. And as a result, you can have many different deployment models. You can deploy Anoma as an L1, as a sovereign chain, global or local, whatever you want. But you can also use Anoma to deploy this as an L1.5, which is really you're trying to decentralize an application on an existing system. For example, you can use Anoma as an L1.5 to decentralize the counterparty discovery and solving component of CowSwap while still being settled on Ethereum. Or you can even, if you want access to the entire privacy-preserving aspect of Anoma, you can also use Anoma as a L2 on Ethereum. And this is really sort of the main message. Anoma loves Ethereum. Like, Anoma does something that Ethereum doesn't do. Like, we don't have any plans to like integrate intents yet. And intents are just this very clean abstraction that allows applications to be built in a fully decentralized manner without relying on sort of AWS not going down or OpenSea not censoring trades. Yeah, so this is bringing intents to Ethereum. And the last sort of minute, I'd just like to introduce the Anoma RFC program. So Anoma is specs first. There are specs for everything. Some specs are better than others, but they're generally specs for the entire system. And they live at specs.anoma.net. We are opening this up for comments, effectively. This is starting, so if you go there, you can find more information. But effectively, if you're a researcher, if you're interested in this space, if you want to see what intents can do actually on an application level, please check this out. The program is starting soon. And we really much welcome other people to contribute here. Yeah, thank you very much. I hope this was insightful, and yeah, thanks.